Hi, I'm Bijan Bowen of the Bijan Bowen YouTube channel. And if you're like me, you're probably interested in local AI. But sometimes it can feel like using the systems that allows you to run these big models is like getting in a time machine and going back to 1988. But I am fortunate enough to be able to today present to you. And of course, yes, the intro was perhaps a little, embellished, but regardless, what if I told you that this base model MacBook Air was actually able to run GPT OSS 120B, all thanks to a little power bank sized device called the Tiiny AI Pocket Lab. Today we're going to be taking a look at something that I've been very excited to get my hands on, and that is this. The Tiiny AI Pocket Lab, or you may also be familiar with this as it does hold the Guinness World Record for being the world's smallest AI supercomputer. Now this, well, it does look like a power bank, actually has 80 gigs of system RAM built into it, as well as a processor and basically everything related to having system RAM. And the whole point of this is to be able to run large language models without needing a very powerful computer to do so. You essentially take this, you plug it into, say, a MacBook Air, which we will be doing for today's video, and it enables you to run stuff like GPT OSS 120B at actual usable speeds, and it doesn't take much power, and it's like quiet and it doesn't get too hot. So this thing really is quite cool, and I have had the distinct pleasure of playing with this for the past few weeks. They were kind enough to send me this and also to sponsor the video, so I will have all of the relevant links where you can find this. It's going to be a Kickstarter, and I'll put them in the description or in a pinned comment or something like that. But I do really have to say, my genuine first impressions of this are, I really do like it. I think it's kind of cute, which I know is probably a weird thing to say about a piece of hardware that I'm holding, but it has a cool ecosystem, and some of the things that are capable with the software and some of the models that they've chosen to have available for this initially do make for a very good time. So let's jump into an unboxing, and then we'll just go through some of the cool things that the Tiiny AI Pocket Lab allows us to do. The unboxing begins with opening the small tiny box, followed by a rubberized pouch that just contains everything we need to actually use our Tiiny AI Pocket Lab. Opening that shows us a user guide, followed by the main event itself, which is of course the Tiiny AI Pocket Lab. Moving on, we have a simple pouch which contains the power cord, power brick, as well as the cord to connect our Tiny to whichever computer we decide to use. Now that we've unboxed it, let's just quickly go through the process to actually plug it in, connect it to our computer, and turn it on. So first off, and this may be a little hard to film, so I have another camera enlisted for its help, we're just going to plug the power adapter in to the port on the side right there. And then following that, there are two additional USB-C ports in the kind of front or side, depending on what angle you're looking at it. And the topmost one, closest to the little tiny logo here, is labeled to PC. So for that one, we just put our USB-C cable in it and then move it over to plug said USB-C cable into whichever computer we're going to be using, which in this case is a MacBook Air. So once it's been plugged into the power supply as well as the computer we're going to be using it with, it's simple. You just press the power button, and then after it boots up, the little white light LED indicator will show up, just telling us that it is in fact turned on. So before we get started, let's just quickly talk about the laptop we're going to be using for today's test and the specifications. This is a 13-inch MacBook Air with an M4 chip and 16 gigabytes of RAM, which is essentially the base model MacBook Air that does exist. I think they did release some new ones like yesterday, but regardless of that, this is still the base specification MacBook Air, and the 16 gigs of unified memory is the important thing to factor in here, as this is a laptop that by itself would not be able to run most, if not all, of the models that we're going to be running on this computer today, thanks to the Tiiny Pocket Lab. So with that, our next step is essentially just to go ahead and open our software. And I'll just use Spotlight Search. So we type TinyOS, and it will open up the TinyOS software. So now that the Tiny is turned on and connected to our computer, let's just get familiar with the actual software that we're going to be seeing throughout some of the duration of this testing. It starts with basically just a chat window right here with Tiny, and from here we can select all of the separate models that we have downloaded on our device. There's a bunch of other stuff in here, but I think for a first look, I'm just going to load in a model, send it a quick message, and we can at least get some familiarity with general use of this and speed and things things like that. So for this case, I think I'm going to opt to go with one of the larger models that this can handle, which is OpenAI's GPT OSS 120B. And as I select that model, we're going to see the circle indicator that shows up to the left of that. That is an indicator that the model is currently loading. So while that happens, I want to talk a little about the hardware in this specific device, because it does relate to actually allowing a lower spec machine like this base model MacBook Air to handle running local AI. So this computer, the MacBook Air that we're using for our testing, comes with 256 gigabytes of storage by default, which is a really low amount, especially in 2026. Oftentimes, local AI models are pretty big size-wise, and the Tiny actually has a 1 terabyte SSD inside it, so it stores all of the models that are downloaded. Basically every model that we see right here in this list when I click on the tiny menu icon is actually saved on the device itself, not on our laptop, because if these were all saved on this computer, there would really be no storage space left for any of your personal files, which would just make for like a unusable experience. So that is something really cool and just keeps everything kind of self-contained, which is nice. So this model is now loaded in, and I'll send it a simple prompt so we can actually see something else that's kind of cool. So I'm just asking it something random, make me a website about Python. We're going to see the general speed here, but following this actual generated result, we'll be able to oh, interesting. So it's making multiple separate scripts. That's fine. We will see the generation speed, as I know a ton of folks are going to be curious about that. So throughout the testing, I will make sure to mention those things. But while this is going right here, I want to direct our attention down to the bottom left, where we do see this little tachometer indicator. And if we click on this, we essentially have a dashboard that shows us the system metrics from our tiny device, such as the NPU utilization, SoC utilization, and the RAM amount as well. And these are things I'll touch upon a bit later in the video, just in terms of some of the hardware arrangement of this specific device, but it's cool to see and have this little usability dashboard that we can monitor. Additionally to that, it also does have a weekly usage of how many tokens you've used, broken down by the specific model which you've used. As we can see yesterday, and when I say yesterday, it was like 30 minutes ago, I was using a lot of the GLM 4.7 Flash model that is listed right here, and it is also uncensored. That is something we have available to us. Regrettably, I won't be able to show too much, if any of that, in today's video, but as you can see, that made up the entire duration of Tuesday's usage with this, which mostly was just kind of some storytelling. So I'll go back right now to the chat window and we'll wait for our result to conclude. We'll take a look at speed and then we'll take a look at the result because I'm kind of curious. And we have received the conclusion of our result, which just basically tells us how to run it. And we can see overall throughout that entire generation, the speed was 17 tokens per second for the GPT OSS 120B model. Now, I should play with this, and the thing is, we're going to see this does have the option to actually preview the result, but being that this opted to use separate scripts for each of this will just look like a very simple basic HTML website that has absolutely no styling or any elements. So I will just download all of these and place them in a folder together so we can look at how this will actually look once stylized. I've now placed all of our generated scripts inside the same folder, and we'll just take a quick peek at this in Google Chrome. Okay, so we have a very simple Python website. It has some hover effects, which is nice to see. Additionally, we also have some sample syntax here for anyone interested, so it kind of went for the educational take on this, which is good to see. But now something, and I have to stop myself because I want to just throw GLM 4.7 uncensored at this and be like, make this hilarious, but I don't know that I'd be able to show that in this video. And additionally, I should probably just showcase more about the actual device. So, but you can see, I mean, in the usage dashboard here, a lot of my utilization has been with that GLM 4.7 uncensored model. So make of that what you will. If you watch my channel, thank you, and you're probably not surprised by that. So let's take a quick peek at this model store that we see here in the side taskbar. And essentially what this is what we think, where it is basically the available models that we can download for this device. Now, you can't just go, as of my knowledge, for the current state of things to Hugging Face and download a specific GGUF or something, because these models are specifically optimized to run at high speed and properly on the Tiiny AI Pocket Lab. And this is something I'll touch upon a bit more when we do have a brief mention of some of the hardware arrangements of this device. So For example, the GLM 4.7 uncensored model is something that was just added a couple of days ago. I was talking to the team about just wanting GLM 4.7 Flash because it is such a fantastic small coding model, but they've also told me that they will be adding Qwen 3.5, which is the new release in the Qwen family, and a lot of those small models will be fantastic to run on this device. So we can see right here that these are what is currently available. We have Mistral models, we have both sizes of GPT OSS. Additionally, we also do have some image capability as well with Alibaba Cloud Z Image Turbo, which is a very fun image generation model, which we will be testing. And then we have some things here like embedding and re-ranker, and these are for RAG specific use cases, which we will touch upon later on in this video. So if we click on the tab right here for owned, these are all of the specific models that I have on my device right here, and they are again contained within the storage of the Tiny itself. As we can see, some of these model sizes we'd pretty much be knocking on the door of what this MacBook Air could actually hold, and that would just not be realistically usable for this task. So that is cool to see. Following the model store, we can see that we have something called the agent store, and essentially when we click on this, a lot of the apps we see right here under my agents have come, well, not a lot of them, all of them have come from this agent store, but essentially this is right now a very early look at, consider it to be, I suppose, like a marketplace of apps that are specifically designed to run well on the Tiiny AI Pocket Lab. So for example, Stable Diffusion Web UI, SillyTavern, which is kind of like a local chat style web interface. If you're familiar with it, then you know exactly what it is, and some of the models here may work very well with that. Additionally, we have some things like Kilocode, Ragflow, N8N is coming soon, which is good since that's so popular with folks, and using this to set up like some local AI workflow with N8N could actually be really quite neat. So you may notice that there's something here called TinyBot in our agent store, which I also do have currently installed under my agent. This is going to be very interesting to a lot of folks, especially considering the rise and popularity of OpenClaw. So I want to highlight this first and foremost. Right here we see TinyBot is a lightweight personal AI assistant inspired by OpenClaw, and essentially this has the ability to link your phone, in my case I have used Telegram, to actually be able to chat with your Tiny AI, whichever model that you have loaded that you would like to speak with from your phone. So we're going to showcase that, I think, as the first agent thing because it's something I set up, and depending on the model you use with it, it can be kind of funny. And we do have the powered by drop-down selection here as well. Qwen 3 8B is the default for a lot of our agents that we're going to see powering them, except of course like the image generation ones. However, I would like to swap over to GLM 4.7 Flash uncensored, and I suppose I should heart this just because, you know. And following that, we just click open, and we see right here, it's pretty simple right now, but the capabilities this allows are kind of fun because I will grab the phone that I have this set up with, and we'll be able to take a peek at chatting with our Tiny language model from Telegram on our phone through a bot. Okay, so bear with me because one, this is like it's hard to film the phone screen, but I need to do it live instead of just like a screen recording. So hopefully we can see right here that I am in Telegram, and I do have the bot set up that I'm chatting with that is directly connected to our TinyBot agent and our Tiny Pocket Lab. So I have just written, write a hilarious haiku. I've sent that now. And essentially we're going to see up at the top somewhere here that it will say the bot is typing, and we also see that our utilization here in the dashboard is going to start jumping up to reflect the fact that we are communicating with our Tiny AI through our Telegram bot. Okay, good. So we did get something. Now I have not yet been able to see, and hopefully it is something I can actually show. It said, snoozing cat on laptop, system error, nap.exe has crashed. Ha ha ha. But regardless, the whole point here is just to showcase the TinyBot agent integration, and of course they said this was inspired by OpenClaw, which, seeing how we're interacting with it from this phone to control everything that's running on this system, definitely will be reminiscent of what folks have seen and wanted with OpenClaw. Now, in addition to that, if I do put the phone down and we go back to the TinyBot application agent right here, we can also use Claude Hub to add skills to this, which a lot of folks have wanted to do because that really enables this thing to behave more agentically and have more intelligence than just being a simple chatbot. Now that we've seen a brief demonstration of this device actually being used, before we go further and play with it a little more, I do want to at least briefly touch upon some of the technical specifics of how this is exactly working. And for this, I'm going to briefly touch upon some of the underlying technology here, but with the caveat that this is going to be almost more of a suggested reading section for anyone interested, but I myself did want to also do some form of at least due diligence in seeing, okay, what is exactly underlying some of the architectural choices and things we're hearing here, such as power infer or turbo sparse and things like that. So depending on one's level of perhaps interest in this sort of thing and level of, I suppose, understanding, as some of this seems to be a bit dense and difficult to kind of digest, I want to just touch upon some of that technology. So first and foremost here, we're going to see there is a GitHub repository by Tiiny AI, and this is called Power Infer. Now, if we scroll down here, we do see, okay, this is open source. There's some other additional information here, as well as a timeline where we can see kind of the evolution of this over time. And essentially the culmination of this is just a CPU/GPU LLM inference engine leveraging activation locality for your device. So essentially, this is, to put it very simply, it approaches this by saying, okay, in a large language model, there are specific parameters, call it unscientifically, that are activated more often than others. So they essentially have found a way to identify those and then be able to ensure that those stay hot or on the neural processing unit of this inbuilt device, which means that they can quickly be utilized in terms of the ones that are not necessarily hot, which would stay on the CPU or something like that, which is much slower. But by figuring out which ones are going to be utilized more, apparently it works well and balanced for a system on the chip device like this to allow reasonable throughput and speed. Now, please keep in mind, this is non-scientific. That is just my kind of surface level understanding of this, having briefly looked at some of the research papers I want to showcase now and just seeing the website here where they do mention it. So if we scroll down a bit more, we can see in an albeit simple graph about power infer that we have these orange little dots here, which are the quote-unquote hot neurons, and those go to the DNPU, which is going to be much faster at actually performing the calculations that allow the model to generate its responses, versus the cold ones, which we see right here, go to the system on a chip, which would be the things like the CPU and stuff like that. Again, this is extremely unscientifically, so please verify everything I'm saying here independently, but I did just want to do some level of mention of the actual underlying technology on this device, because I find it personally very interesting, and also when I test things like this, I want to do more than just like, hey, here's what I can do with it, cool, like, take care. So with that, I'm also going to just briefly at least put on screen, these are two specific research papers that are correlating with the technology stack that is underlying this specific device and some of its capabilities. So I do also want to prominently display these just for anyone interested in looking more at how this works, because these do also seem to have some pretty cool ramifications for running things on edge devices, even like cell phones and stuff like that. So it's interesting from a research perspective, I suppose, could be said as well. And I wanted to provide, as I've probably said a million times by now, just a little bit of a technical look. So with that all out of the way, we can go back into kind of just playing with this, and what we can see right here is I've transitioned into just using the text-to-image capabilities here from within just the TinyOS chat window, which truthfully I do prefer. However, I should now mention that one of the available agents, as we can see here in the left-hand pane, is of course the Stable Diffusion Web UI. So if we click on this and we click open, we are going to be brought to a very simple Stable Diffusion Web UI, which has a lot of potential options, and to be honest with you, understanding how to use this sort of stuff is definitely like an art in and of itself, because there's so many different options and ways to tweak the output image generation quality that I just find it simpler to do it from within the chat window, because I'm not really that picky about some of the generated results. But being that we do have the Z Image Turbo model selected, as we can see right here, also reflected by our model selection pane, I'm just going to give it a relatively simple image generation prompt so we can see how it does in real time. And I'm just saying, generate a photo of Bijan Bowen. Let's do 4K Ultra HD realistic. I don't know, like, we'll see how that does. And we can see currently it is generating this at a resolution of 512 by 512 with 20 sampling steps. So upping the sampling steps as well as the resolution will inevitably slow down the generation speed, but the upside of that is it will produce a higher quality result. Okay, so here's our ultra realistic 4K Bijan Bowen image. I think maybe we can do a little better. So Let me bump that to 40, and then we'll bump this resolution to 1024 by 1024. Following that, we'll change the photo topic. Generate a photo of a retro LAN party taken in 1998, 4K Ultra HD realistic. And we're going to see this will take a bit more time because it's going through more sampling steps, which hypothetically will produce a more detailed result, although there is like a threshold where that doesn't tend to be the case beyond a certain amount. And then also we've upped the resolution to 1024 by 1024. Now, I'm seeing some interesting things right here because a retro LAN party would be like a gaming PC party. Now, this almost looks to be some form of New Year's party. Nonetheless, I suppose we'll take what we get, and really the whole point of this is just showing the speed. This almost looks like a... I have to really bite my tongue here, especially keeping in mind that this is a video to like demonstrate this as a product. Regardless, it's almost finished. Again, I'm probably going to hold off on saying anything there. Generate a photo. We'll try a few more of a vintage computer store 4K Ultra HD realistic. So here's our generated photo of a vintage computer store called Chizu Finds. And we can see that there are some retro computers in here, very retro and small aesthetic to the storefront as well, I would have to say. Rather interesting. Now, I would like to do at least a couple more, but I'm going to opt to just use them through the actual chat interface here, as I may have said I like it better. So I just said make an image of a car, and it gave us this very happy smiley cloud cartoon style look. And we'll see what it makes of this specific suggestion. Very interesting. It gave us definitely a far more masculine looking car. It does look overall like an Audi. That hood is definitely like an Audi A5, although these headlights do look like a Jaguar sedan, one of the like smaller ones. I forget what they're called. And then we have a wing at the back. Very interesting. Definitely, though, I would say between the two, this second one is more representative of a quote-unquote alpha male looking car. So, not bad. So now I'd like to go ahead and actually just showcase pulling one of these agents from our agent store. In this case, I'm going to want to play with Kilocode Tiny, which will just allow us to do some simple vibe coding with VS Code using a model running on the Tiny. For this, I will likely opt to use GLM 4.7 Flash since it is a really strong model, especially for the footprint. So right now, we don't have to actually worry about which specific model it's showing that it's powered by. We're going to just press get, and the thing about this one is it just downloads it as an extension, and then it's going to basically tell us drag this into your VS Code extensions window, and then you'll be able to have this enabled. So I do have a fresh install of VS Code right here, and then if I can manage to wrangle these windows, we're going to drag this right here into our extension window as we had just downloaded it from the Tiny agent. Okay. And then following that, we now have it right here as our extension, and we are going to just click get started. Now, prior to doing this, because this I have not done before, this is genuinely the first time I've played with this, and I do that on purpose because I want to highlight the actual user flow of this. So I'm going to go into the menu icon right here. I'm going to unload ZImage Turbo by just clicking the eject button, and following that, I will find GLM 4.7 Flash. I will opt to use the normal one, not the uncensored version, although that would make for some rather flavorful code potentially. And then once that's loaded in, I will actually figure out how to use this. We can now see, just based off of clicking on the menu icon right there, GLM 4.7 Flash has successfully loaded on the Tiny. Following that, I did just increase the zoom in this IDE because it was pretty hard to see. So now we're going to click on the settings right here in Kilocode, and we see the model is automatically selected right here, being that it is loaded in as we initiated that in the menu icon right here. So were I to actually eject this right now, we could see, okay, say I want to load in Qwen3 Coder 30B instead. Once that has concluded loading in, and again, we'll see that progress bar right here just showing us while it is actually loading, then it will show there instead. And now we can see the model has finished loading in. So it has also changed here to reflect the currently loaded model. However, I do want to use 4.7 Flash, so I'm going to now eject that and then reload Flash. I think I will initially start it in the architect mode, and let's give it something a little more complex than just a static web page. I'm asking it for a simple 3D flight game, and then it's going to, okay, this is just something in terms of my specific system here. We can ignore that. It's going to, in plan mode here, now architect out the specific implementation plan, and we'll be able to see in real time actually vibe coding with the Tiiny AI Lab. And we can see it took a little while to think and to initially process the request. We can see it had a relatively lengthy chain of thought right there, and it is now just asking us some follow-up questions, such as all of these. What type of flight game would you like to create? This works, a simple airplane flying over terrain with keyboard controls, WASD for arrow keys. Good. And it has now decided it's going to make a simple 3D airplane game using Three.js. It's now outlining the plan, keeping in mind that we did begin it in architect mode, which is essentially what we see going on right here, where it is architecting everything out. And we can see it was starting to write the file, and then it was like, wait, I need to switch to code mode so that I can actually go ahead and do this. Kilocode wants to switch to code mode because it needs to do that in order to actually create these specific files, which is fine. At the same time, I'm going to close out of the default VS Code walkthrough pane that had been open there, just so we can actually get a better look, focused more on what's going on here. And we can now see the code has begun to be written, which is quite exciting. Now for this, I'll probably just let it go. I'll time-lapse this inevitably, and then I'll just wait till it's actually finished, and we'll try the result. If it needs some improvements, we will kindly yell at it to tell it to do so. So with this plugged into a base model MacBook Air, we are now vibe coding with GLM 4.7 Flash, just using local AI with the Tiny hooked up to this MacBook Air. So this is essentially like the whole point of this device, is to enable things like this with computers that otherwise would not have the capability to do so. Now that the scripts have been concluded, it's just updating the to-do list to reflect the progress where all tasks have been completed, which we can see right here. So our next step is just going to be to actually test this, which I will do, unless it's going to do it. I would prefer to do it, but regardless, this is more kind of in line with agentic coding, where ideally you would not have to do those things. This is actually good. Okay, I'm glad I allowed it to do this, because it also shows that this is able to run some simple commands and things like that, which are required for agentic coding such as this. Okay, so it's supposedly now going to launch the browser to test the game. Okay, so Chromium is open. Okay, so what we see right here with this mmproj, essentially it's trying to look at an image of this and it's unable to, so that is specifically what would relate to what we see right here. So regardless of that, I'm going to instead perhaps just actually run this manually, which is probably better, but we do see that it did actually open Chromium there and try doing some things. Unfortunately, the issue was when it tried to send a message. I do not believe GLM 4.7 Flash is multimodal, so that would attribute to that. Regardless though, this is located in Documents Flight Game, so let's just take a look at it. Okay, and to be honest with you, that's not bad. That terrain generation, okay, so the plane now we see may have a bit of an issue, perhaps we're initially taking off, but regardless, this is actually a really solid generation from this model, and GLM 4.7 Flash has a fantastic ability to code. This terrain generation, even the plane model is relatively plane-like, which to be honest with you is pretty good, and this is something that like a year and a half ago, getting this result from a significantly larger model would have been impressive in and of itself. But now we have little local models like this actually being able to put this out. And this was on a first try without actually doing anything to it at all. Like I didn't tell it, no, fix this or make this better. So the plane kind of being a little awkward in terms of its flying characteristics. Oh, space is boost. I didn't check that. Okay, good. And the terrain is really quite well done. I mean, this terrain is better than some of the stuff I see like nowadays. So overall, I mean, you know, if you watch the channel, you know, I very much like this sort of stuff. So I'm impressed with this. So I wanted to showcase this, and this specific thing we see right here is just because Kilocode thought this was a vision capable model. It is not, so that is what is attributable for that error. So that's not actually like anything bad happened, but nonetheless. So let's see, I think I started this at 1:48 a.m. Correct, I did. Right now I use only analog clocks. It's like 2:10, give or take a few minutes. So say this took around 20 minutes or so. And the thing is, it's not necessarily even like the speed. It's reasonable, especially considering it actually gave us a functional result, and it did have to function agentically here, meaning the prompts that were sent to it would have taken longer for it to actually even process. The whole point of this that I definitely wanted to showcase is this is not using some really butchered, nerfed model to actually be able to fit it and run it at a reasonable speed. This is using a model, as we just saw, that actually did a really quite solid job at putting out a simple 3D plane simulation game without any errors on first try. And I want to highlight this as something that I've noticed in playing with this is obviously you could have a device, I could quantize a model to like 1 bit and fit it on pretty much anything and it would run very quickly, but the output would be absolutely atrocious. So I wanted to do this specifically because it shows us that it's actually like the model is still potent and performing quite well. That flight game really was actually quite decent, especially considering, I mean, this model is very performant anyway. So I just wanted to showcase this as a specific demonstration that kind of speaks to me, and I know a lot of folks are probably going to be interested in actually seeing this do something. Now, I'd just like to almost sort of honorable mention some of the other agents here. One of them is this RagFlow, which essentially could be very powerful, especially for more business or PII use cases where you have data you don't necessarily want to go to the cloud. This essentially allows you to use one of the models included with the Tiny, and you actually would load multiple in at the same time, which is kind of cool. So if I click on this right here and we scroll down, we do see that I have 3 models currently loaded on the device. One is just Qwen3 8B, and the other 2 are specifically related to actually performing RAG, or just to simply think being able to give it your documents or some form of knowledge base contained in documents, and then ask it questions about said documents. So this is another thing that's enabled here, and it is really cool just to have that capability. RAG is something that is very commonly used across a lot of different use cases, I suppose could be said. So I wanted to just briefly touch upon this as well. Additionally, there is also something called SillyTavern, and this is something that if you are the type of person who would want to use this, you very likely probably are aware of it already, but you can probably get a little bit of insight just from the photo that is shown right here. Your private AI character chat, and especially coupled with the uncensored GLM 4.7 Flash model, this could be very fun for roleplay use cases in chatting with an AI or having a fun little companion to speak in colorful manner to yourself using SillyTavern. So it is just cool to see that as well. Now, the last thing I want to do is just load in some of the models I have downloaded on the Tiny device here and just talk to them so we can get a measure of speed. I won't be giving them massive walls of text or insanely difficult tasks, but enough to just give us a general sense of speed over a perhaps mid-sized generation. I think to begin, I actually will opt to use Qwen3 Coder 30B, so we'll load that in and give it a simple task and then take a look at the speed and probably also the generated result. I've just sent it the prompt, make me an educational website about snakes, and keep in mind, okay, so sometimes this is what happens with smaller models, is instead of actually generating the website for you, they just generate an outline of what they would have put on said website. So following this, and this will just give us a little more like preloaded context that gets longer to work with so we can get a more accurate measure of speed. I will just tell it like, no, I wanted a website result, not this outline. And we can see that total generation was 25 tokens per second. Now I'm going to tell it, cool, but I need this actually in a website. Good, and now it is properly creating said website. Alright, we've received our Snake Education Center website generation, and we can see it's still going at a definitely reasonable speed right here. Once it does show us the specific token figure, we will then look at the website. I'm going to say I'm actually interested. Okay, so that was 21 tokens per second. I'm rather interested in seeing this website because it does seem like it did a wow, yep, that is the traditional like Qwen3 coder style background gradient color, but here is our Snake Education Center website, and I do like this little stylistic snake, if you will. And we can see, okay, this is actually rather intricate. We have some snake basics, we have types of snakes, we have snake families. This model seems to have an oddly large amount of knowledge on snakes for a specific coding model, but regardless of that, even look at this. It's drawn some pretty little images here for climate adaptations, feeding and behavior. We also have conservation, and then we have why snakes matter, and a nice footer here as well. So truthfully, I'm actually really quite curious to see how many lines of code this was, because it did seem to really go all out. Okay, so that was around 710 lines for our Snake Education Center website, which was pretty good. So let's try a dense model now. In this case, we'll just do Qwen3 8B. Now this, we probably don't want to have it make anything. We'll just have it perhaps tell us a story. And we'll see what it does. Now Qwen3 is a thinking model, and this has thinking enabled right now. So first and foremost, we're just seeing the chain of thought. All right, and we received a interesting story there, and that was a speed of 18 tokens per second throughout all this, including a 41-second chain of thought. Now, I think the next model I would like to just test it with is probably GPT OSS 120B. Even though we did already see a little bit of that model performing, I want to just show it again, I suppose. And in lieu of making a new chat, I'm actually just going to have OSS 120B start from this, so it has a larger prompt to initially process before it even begins generating what we ask it to. And we'll see how it does. All right, so after a very, very lengthy story that I will be honest, I didn't necessarily read word for word. I kind of did just skim along with it. We see that GPT OSS 120B gave us 14 tokens per second, keeping in mind that we did start it out with a relatively large prompt, being that our first kind of response to it was to give it this entire story that Qwen 3 had generated and then say make this story way better and longer. Now, for our last model speed test, I'm loading in GLM 4.7 Flash uncensored, and I'm just going to ask it to make me a funny website. And we'll see what it does. I would imagine I will be able to show this, but you never know. All right, so we received our result. There was a 77-second chain of thought as well about the result prior to even generating any code. The speed was 16 tokens per second, and I am quite curious to see this. Wow, okay, so we have the official guide to being useless. Why be productive? You'll just get tired, you'll just get old. Why not just sit there and look at a wall for 3 hours? Okay, let's click the I want to be useless button, and it gives us some confetti. Wow. So again, this is, what even is this? Create a fake meme, enter a phrase, and click the button to see it on a generic stock photo. This model really is good. And keep in mind, this was the uncensored variant. I have to also remind myself that we were just testing the speed. We weren't even testing the... When asked how are you, say I'm functioning at a subpar level, it makes you sound mysterious. If you're working, stop. The universe does not need you to finish that report. Take a nap instead. Tip 3, do not drink water when you're thirsty. Wait 10 minutes. By then you will have forgotten you're thirsty. That is terrible advice. When the GPU hits, I have no idea. I don't even know if this is actually going to overlay the text onto this. Yeah, okay, just gave us more confetti and then changed the stock photo. Okay, regardless, products we don't need, and then celebrate failure with more confetti. Wonderful. That is probably, seems like a natural ending point of this video. So let's just talk a little bit about this and my honest thoughts on this device, and yeah. One more confetti. All right, so I'm just going to turn this off now so I can hold it for the outro, because it will seem more fitting to just give some more visual feedback on this device and its design, and then I'll talk about my honest, genuine thoughts in using this and having it. To be honest with you, I really like this thing. I know that there are going to be a lot of folks who will be like, well, no, you know, it's too slow, or the price, or something like that. To be completely honest, this is a rather unique device because nothing like this exists. It can run GPT OSS 120B, although to be honest with you, you'll probably have better results with GLM 4.7 Flash or Qwen 3.5 once they have that available for this as well. I will say, I just unplugged it and grabbed it. This thing does not get hot. I mean, I would guess, I don't have a thermometer on hand. It's like, it's not lukewarm. That would be colder than it is, but it's like kind of warm. It does not get hot. The fan is, I won't say it's loud, but for the size, it can produce a little bit of noise. So keep that in mind if you have it on your desk, but it's not going to overwhelm anything. The form factor I do absolutely love, and the power draw. They say it takes 30 watts and it's using a 65 watt USB-C power adapter. So this thing, from an actual efficiency standpoint in terms of actual like power or electricity costs, is fantastic, and that is definitely somewhere it excels. Additionally, the form factor and kind of what it enables. So this is a base MacBook Air that we used for the entire duration of today's testing, and that I have been using with this since I received it. And this is a computer that otherwise would have no hope of actually being able to run these models locally. The alternative to being able to do so is buying something significantly more expensive, like a whatever 64 gig MacBook or 128 even perhaps, or you could just build like a big beefy desktop with a big GPU. Both of those, sure, they will be faster to run these models. However, they draw so much more power, they're more expensive, and they're significantly just less efficient overall. Now, I haven't even really talked about the software, and I almost think that speaks well to it because I'm so focused on the device. If the software had been bad and made me angry, I would definitely have initially spoken about it more, but really, I'm almost more impressed with the device. The software works, and it is perfectly good for what the purpose it serves, which is essentially what you can ask. It's simple, it's intuitive. I've updated this thing probably 3 or 4 times since I received it, and nothing's gone wrong. You just kind of keep it attached, you allow it to update itself, and then it reloads the app and everything seems fine, at least for the 3 or 4 times I've done that. In addition to that, I want to see some more development in the agent store and also some more models being added, but I have to keep in mind that I'm probably one of the initial folks who actually has one of these because influencer status. But realistically, I mean, for the early point in this thing's life cycle, it's actually still pretty well polished. I wanted to give a genuine look at this thing and showcase some actual useful things. I really do, and forget any like sponsored stuff, things like that. I really like this thing. I genuinely really do like this thing. It's going to be available on Kickstarter. I know folks are always very polarized on Kickstarter, and I totally understand that. To that, I can say that this is in my hand. I've been using it. It does exist, and it actually works quite nicely. So that's probably going to conclude this first look and review of the Tiiny AI Pocket Lab, the Guinness World Record holder. So with that, that is going to wrap up today's video. If you have any questions, please feel free to leave them in the comments. There will be more pertinent information linked either in a pinned comment or in the description about this little guy. And thanks for watching.